Today we're going to be working with sine and cosine ratios. So the sine of angle A is where we take the opposite leg, which is the length of BC, divided by the hypotenuse, which is the length of AB. Cosine is where we take the adjacent leg of angle A, so AC, divided by the hypotenuse, which is AB. So let's use this to look at our first example. We want to find the ratios for the cosine of x as well as the sine of x. So if we're looking at our degree, which is x, so we're looking down here, the 26 is our hypotenuse, 24 is our adjacent leg, and 10 is our opposite leg. So in order to find the cosine is the adjacent leg divided by the hypotenuse. So the adjacent leg is 24. We're divided by the hypotenuse, which is 26. So if we reduce this, 2 goes into both. 24 divided by 2 is 12. 26 divided by 2 is 13. So the cosine of x is 12 over 13. So then the sine of x is the opposite leg divided by the hypotenuse. So if we're looking at the opposite leg, it's 10 divided by our hypotenuse, which is 26. So if we reduce that as well, both of them go into 2. 10 divided by 2 is 5. 26 divided by 2 is 13. So the ratio of the sine of x is 5 over 13. So we have a right triangle. We have triangle ABC. We say that the sine of angle A equals 1 divided by 2. Remember, when we're working with the sine, it's the opposite divided by the hypotenuse. So the hypotenuse is a 2, and the opposite of angle A is a 1. So what we need to do is we need to find that third side length so we can find the cosine of A. So to find our third side length, we're going to use the Pythagorean theorem. So 1 squared plus x squared equals 2 squared. So 1 plus x squared equals 4. And then we have x squared equals 3. So when we square root both sides, we're going to round to the nearest hundredth. So the square root of 3 is 1 and 73 hundredths. So the length from A to B is 1 and 73 hundredths. So to find the cosine of angle A, it's the leg that's adjacent, which is 1 and 73 hundredths, divided by the hypotenuse, which is 2. And since we want to solve for it, we want to know what that degree is. We're going to take the inverse cosine of 1 and 73 hundredths divided by 2 to find that angle A. So we have the inverse cosine, 1 and 73 hundredths divided by 2. So angle A, we're going to round it to the nearest degree. It's about 30 degrees. Let's find the value of x to the nearest tenth. So here, if we're working with the 26 degrees, 7 is our hypotenuse, 26 is our opposite, and then here's our adjacent. So that means we're working with the opposite and the hypotenuse. So that means it's going to be the sine of 26 degrees equals the side opposite, which is x, divided by our hypotenuse, which is 7. So the sine of 26, round to the nearest tenth, is 4 tenths equals x divided by 7. So we want to create a proportion so we can cross multiply to solve for x. So 4 tenths times by 7 is 2 and 8 sevenths. Or sorry, 2 and 8 tenths. And 1 times x is x. So x equals 2 and 8 tenths. Let's find the value of x to the nearest tenth again. So here, x is our hypotenuse, 16 is our adjacent, and this is our opposite side. So since we're working with the adjacent and the hypotenuse, we're going to be doing the cosine of 29 degrees equals our adjacent, which is 16, divided by our hypotenuse, which is x. The cosine of 29 degrees to the nearest tenth is 9/10, which equals 16 divided by x. So we create our proportion. So 9/10 times by x is 9/10 x, and 1 times 16 is 16. So we divide by 9/10 to both sides so we can solve for x. And 16 divided by 9/10, rounding to the nearest tenth, is 17 and 8/10. We want to find the value of x to the nearest degree. So here, our hypotenuse is 20, 17 is our adjacent leg, and this one's our opposite set leg. So since we're working with the hypotenuse and the adjacent, it's going to be cosine of x equals the adjacent, which is 17, divided by our hypotenuse, which is 20. So we're going to take our inverse cosine of 17 divided by 20 to find the degree of x. So the inverse cosine of 17 divided by 20, rounded to the nearest degree, is 32 degrees. So here if we want to find the measure of angle x, 26 is our hypotenuse, 24 is the adjacent leg, and 10 is the opposite leg. So here we can use either sine or cosine, so let's look at both. So let's start with finding the cosine of x, which is the adjacent over the hypotenuse, so it's 24 divided by 26. So that means we're finding the inverse cosine of 24 divided by 26 to find that degree. So the inverse cosine of 24 divided by 6 to the nearest degree is 23 degrees. So let's see what happens if we did using the sine of x. So the sine of x would be the opposite leg divided by the hypotenuse, which is 26. So that means we would do the inverse sine of 10 divided by 26 will equal x. So the inverse sine of 10 divided by 26, rounded to the nearest degree, is 23 degrees. So it doesn't matter which way you use, as long as you set up your ratio properly, you'll end up with the same solution. So here we have that Leola drives up 130 meters up a hill. So she's driving up a hill, and it's 130 meters. And it has a slope of 7 degrees. So if this is horizontal, she's driving at 7 degrees. We want to know what the horizontal distance is. So what is this length here? So this is our right triangle. So 130 meters is our hypotenuse. This is our opposite leg, and this is our adjacent leg. So since we're working with the adjacent and the hypotenuse, we're going to be taking the cosine of 7 degrees equals the adjacent, which is x, divided by our hypotenuse, which is 130. So the cosine of 7, and this says to the nearest hundredth, cosine of 7 will be 0 and 99 hundredths equals x divided by 130. So we can create our proportion, cross multiply. So 99 hundredths times by 130 is 128 and 7/10 equals 1 times x, which is x. So the nearest hundredth, what's the horizontal distance that she's covered? She's covered 128 and 7/10 meters.